Department of Zoology, AGC Pune. So I request you to take your seat, and it will be started soon after the tea break.
Good noon, friends. We are going to start our subplenary on scientific temper and science communication. The specific topic chosen for this subplenary is ancient Indian scientific tradition. Obviously, with its limitations also, it will be discussed today. And the session will be chaired by S. Krishnaswamy, Professor, Madurai Kamraj University. I request Professor Krishnaswamy to come to the dais and take his chair. The speakers of this session are Dr. Ashish Lahiri of Pavlov Institute, Professor Somok Rai Choudhury, Vice Chancellor of Ashoka University, and Dr. Gauri Haval, former Head Department of Zoology, Garwari College, Pune. I request Ashish Da, Somok Da, and Gauri ji to come to the dais. Dr. Gauri Haval. Yeah. Now I request Sujata and Dr. Nirmallo to felicitate our honored dignitaries with the flower bouquet. That particular flower bouquet was prepared by the lady science activists of Paschim Banga Vigyan Mancha from biodiversity products. তুমি দিয়ে দাও নির্মাল্য তুমি দিয়ে দাও তুমি দিয়ে দাও Thank you. Friends, since 2022, we took several programs throughout India to develop scientific temper to fight the irrationalistic view which was being spread by the ruling dispensation. All of we know that Kolkata Declaration on Scientific Temper 2024 was a product of all these movements which was initiated by AIPSN and which we are still continuing. साथियों, ये कोलकाता डिक्लेरेशन का बाद हम लोग ने ये तय किया ये लड़ाई हमको और भी चलाना पड़ेगा, बहुत दूर तक हमको जाना पड़ेगा. Friends, we know there are two potential things of our country. First one is our diversity. India is a land of diversity. There is a diversity in terms of languages, there are diversity in terms of dresses we wear, diversities are in our food and in our cultural practices also. This plurality gives us strength. This plurality is the strength of India. our ability to respect and appreciate these differences and learn from each other forms the cementing bond of Indian civilization. भारत की संस्कृति, सभ्यता, ये जो बहुमत है, ये जो डिफरेंसेस है, कल्चरल डिफरेंसेस, खाने का डिफरेंसेस, पढ़ने का जो पहने का डिफरेंसेस है, उसमें से एक अन्य के साथ एक बॉन्डिंग उससे ही पैदा होते हैं. वो बॉन्डिंग हमारे देश के बहुत ज़रूरत एक स्ट्रेंथ है, बहुत एक अच्छा स्ट्रेंथ है. ये पहला स्ट्रेंथ हमारा है, इसको सोचना पड़ेगा. दूसरी हमारा एक स्ट्रेंथ है, वी एज सिटीजन्स हैव द राइट एंड ड्यूटी टू डिबेट व्हाट इज राइट एंड व्हाट इज रॉन्ग, to preserve whatever is good and useful, and to discard the undesirable concepts and practices based on evidence, critical thinking, based on reasoning. We may disagree with another's opinion, but we must agree with and defend the other's right to hold that opinion even while seeking to dispute or debate it. This process of open discussion, critical thinking, plurality, evidence-based reasoning, and opinion forms the cornerstone of democracy. This is the cornerstone of democracy. गणतंत्र का यही एक बहुत ताकत वाला शक्ति है, and the scientific temper also that we committed to do. So scientific temper के लिए भी ये disagreement, dissent, debate, critical thinking, reasoning, evidence-based reasoning इसका ज़रूरत है. So the plurality and the scientific approach are now being threatened. That is the reason why we actually selected this particular topic. ये जो मुद्दा हमने उठाना चाहते हैं, क्योंकि प्लूरलिटी ऑफ इंडिया और जो साइंटिफिक अप्रोच वो आज बहुत खतरे में है. And that was threatened by the forces of intolerance and obscurantism that seek to divide Indian society and use different forms of coercion and intimidation, including thought processes and including activities also by violent means to silence the dissent, to silence the critical thinking. So our task is now very important and very critical also. And at this juncture, we are discussing on a specific topic because everybody says that in ancient India this was there, that was there, some myths are associated with it, something true, some half-truth, and some false things are being propagated. And so we have to actually know what actually was our cultural heritage, our scientific heritage, and that will be discussed by the respected speaker, Dr. Ashish Lahiri. He will speak us on the ancient Indian materialistic outlook. All of you know that India was considered as a country of mystic ideas, idealistic ideas, but materialistic outlook was also there in India, and that will be revealed by Ashish Lahiri. Professor Somok Raychaudhuri will talk on specific topic, ancient Indian mathematical and astronomical heritage, which actually India possesses, and Dr. Gauri Habel will speak before us what the medicinal and the biological traditions which we are actually wearing. With this short briefing, I am handing the microphone to Chairperson Krishna Shamiji to continue this session. Thank you.
Morning everyone. It gives me great pleasure to invite on behalf of AIPSN Dr. Ashish Lahiri of Pavlov Institute to deliver his discussion talk on materialistic outlooks in ancient India. 30 minutes.
Thank you, ladies and gentlemen. I must say I'm rather elated to have the opportunity to talk before such a nice attendance. I've never come before. I've not attended this kind of all India conference of yours before. So I was really impressed. I was talking to the organizers that so many people are interested in listening to this kind of talk. So with these few words, I come to my actual topic. As Arunabu Babu was telling, pluralism in India has all along been there, even in philosophy. If we go to the history of Indian philosophy, or rather Indian philosophies, we find there is a lot of pluralism, lot of diversity in them, whereas nowadays we find that one particular kind of philosophy, not nowadays, I think it is probably it itself has got a tradition of promoting only Advaitavad or Mayavad or Shankaracharya's philosophy as the only or the most important philosophy. This has started with Swami Vivekananda. He was a great adherent of Advaitavad, and even in America and in other countries, he promoted India's philosophy as mainly based on Shankaracharya's Mayavad, which is historically debatable. So I'm placing here, I'm not a specialist in this, so, and I do not know Sanskrit. So whatever I am telling, I have based my findings on the great Akhay Kumar Datta, who was a contemporary of Ishwar Chandra Vidyasagar. He was born in 1820 and died in 1886. And then we have recently lost Dr. Ramakrishna Bhattacharya, who has done a lot of work on Charvak philosophy. So based on these two, I'm placing what I want to talk to you. So theism, atheism, skepticism, all these are parts of Indian philosophy, contrary to what is normally taught to us. Now, according to the classifications made by the great Akhay Kumar Datta, we can see that we can categorize the various strands of Indian philosophy into two groups. One, the Vedic philosophies, means these philosophies, they take Ved as incontrovertible. They all accept that Ved is true. Sankhya, Yoga, Vaisheshika, Nyaya, Jaivini, Vedanta. So all of these philosophies in this group, they have much difference between them. One is much opposed to them, but they all fall in the single category of Vedic philosophers. For example, what we call Astik and Nastik. In Bengali at least, we understand Astik means one who believes in God, and Nastik means one who does not believe in God. But if you go to Indian philosophy, the meanings are different. Astik is those who believe in the Vedas, who believe in the incontrovertibility, infallibility of the Vedas. They are called Astiks. So even though Sankhya philosophy, it does not believe in God, but it does believe in the incontrovertibility of the Vedas. So it falls within the Astik category. Whereas the non-Vedic philosophies, Buddhism, Jainism, and of course Charvaka or Lokayata, which is frankly materialistic. So if we just change the arrangement, we will find a different picture coming out from this. If we categorize Indian philosophies, those who believe in theism, those who do not, then we find that atheistic and skeptical philosophies, number one, Shankho, which says, once again I say I do not know Sanskrit, but I know this much, that Ishvara Siddhe Pramanavat. Because of lack of proof, the existence of God is not permissible. That is what was written by the Shankho philosophers. Then Vaisheshika. Vaisheshika, as we know, the Paramanu concept, the atom concept was put forward by Vaisheshika. Nyaya is a book of logic and methodology. Then Jaimini, Buddhism, Jainism, I shall come to them later once again. They do not believe in God, though they have much differences in their interpretation of the world. And finally Charvaka, they do not believe in anything. They do not believe in the Brahmanas, they do not believe in religion, they do not believe in the soul, they do not believe in God. Whereas the frankly theistic philosophies, we find only two, the yoga and Vedanta. So this is the other kind of categorization based on Akhay Datta's classification. Now, Shankho is a dualistic, as I said, Astika school of Indian philosophy regarding reality. Human experience, according to Shankho, human experience is constituted by two independent ultimate principles, Purusha and Prakriti. Here Purusha does not mean male. Purusha is the active principle, Prakriti is the inactive principle. And it denies the concept of God. Actually, it explains the entire universe by taking recourse to 24 entities, 24, specifically 24 entities. That is why the name Sankha, the 24 numbers. But when we come to the next yoga philosophy, it is practically the same as Shankha philosophy, with the exception that Patanjali said, if we do not add another entity named God, we cannot explain the universe. Hence, it is also called Sheshar Shankha, Sa plus Ishwar. That is Shankha with God. Shankha original was without God, and Shankha with God is Patanjali's yoga philosophy. Then, as I said, Nyaya, it deals with the methods of proof. What is logic? We know they have identified 4 kinds of proof. Number 1 is perception, pratyakha. What you feel, what you know, what you see with your eyes, taste with our tongues, like that. Then there is anumana. You infer something. You do not see the thing, but you can infer something by seeing others. So this is the anumana or inference. Then analogy. You see something and you compare it with others to come to a conclusion. So the most dangerous is the last one, that is testimony, which is called shabdo, or some people say it is used in the adjective, that is shabdo, means testimony. Vedas, we do not need any other proof. If someone says this is mentioned in the Vedas, that is proof enough for its truth. And Nyaya also says that there are certain things which we see, we often opine about, but there is no valid proof for that. Those are called invalid knowledge. They involve memory, doubt, error, and hypothetical argument, unproven argument. So these are called invalid knowledge. But the most dangerous is testimony. And unfortunately, nowadays, this testimony part, the shabdo part, if something is written in the Vedas, we do not have to think about it. It must be true. Then we have Vaisheshika, probably the most important of the Indian philosophies. Why? Vaisheshika was a form of atomism in natural philosophy. It postulated that all objects in the physical universe are reducible to paramanu, param plus anu, which is the ultimate particle, paramanu. And one's experiences are derived in the interplay of substance. Means a function of atoms, they define substance as a function of atoms, their number and their spatial arrangements. Although they did not perform any experiments, but these philosophical ideas were there. Quality, activity, commonness, particularity and inherence. And everything was composed of atoms. Qualities emerged from aggregates of atoms, but the aggregation and the nature of these atoms was predetermined by cosmic forces. Nowhere God is mentioned. And they even say that atoms are the ultimate reality. There is nothing beyond the paramanus, no concept of God. But all these things changed, mind you. During the Middle Ages, all these philosophies were changed and the concept of God was imposed on them. But in the original form, they did not bring God to explain nature. Mimamsa. You know, Acharya Kumar Datta, he gives he translates into Bengali one passage from Mimamsa. In the passage it is said that someone is praying to God Indra. There is a yajna and someone is praying to God Indra that, oh Lord, you please come and you reside in this ghata, this pot. And the Mimamsa philosophers, they are ridiculing this by saying that if the Lord Indra comes, he will not come alone. He will be seated on the Airavata, such a big elephant. And if that big elephant resides in this earthen pot, what will remain of that? Now this kind of ridicule was there in the Mimamsa darshan. So they did not deny the ultimate God, but they did not believe that God, they did not believe in the gods. That is, prayer is unimportant. You cannot bring down something which is not there in the universe. You cannot bring down God, Indra, to fulfill your desires. This kind of ridicule was there in Mimamsa philosophy. Then the great Vedanta. Advaita Vedanta, particularly, there are many forms of Vedanta, but the most popular is Shankaracharya's Advaitavad, Mayavad. Advaita Vedanta espouses non-dualism and monism. Brahman is held to be the sole, unchanging metaphysical reality and identical to the individual Atman. So there is Atman, there is a Brahman. The physical world, on the other hand, is always changing, an empirical Maya or illusion. The world we see, this hall, these people, this mic, all these are Maya. Only when we will wake up, our internal knowledge will tell us that all these are non-entities. Brahma, if you read the Brahma Sutra, it's clearly written that reality is not reality. Only reality exists in Brahman. And this Brahman is unmanifested, abhyakta. It has never been manifested. So these are the major 6 streams of what we call Hindu philosophy. About these 6, after discussing in detail, pages after pages, the great Acharya Kumar Datta summarizes his findings like this. He wrote in Bengali, and unfortunately his book, as yet, has never been translated into English or any other Indian language. So people outside Bengal, even inside Bengal, very few people know about this great man. Someone should take the initiative to translate these writings into English so that it can be read by so many other people outside Bengal. So Acharya Kumar Datta says, none of the formulators of these 6 philosophies, means Shara-darshan, of these philosophies have accepted an auto-creator of this world. Shankha of Kapil is atheism, plain and simple. Patanjali, no doubt, believes in the existence of God, but he has characterized God as only the maker and not the creator of the world. And he defines what is the difference between a maker and a creator. A creator creates something out of nothing, but a maker makes something out of the ingredients already available. So Patanjali defines God, who already has before him the ingredients for making the universe. He is not the creator, but only the maker. According to the systems of Gautama and Kanada, that is Vaisheshik and Nyaya and Vaisheshik, material atoms are eternal. They have not been created by anyone else. Ancient Mimamsa scholars have categorically denied the existence of God. And Vedanta says, note this world has never been created at all. It is unmanifested, has never been created at all. The phenomenal world is nothing but an illusion. So how does the question of a creator arise? If you believe in Vedanta, you cannot believe in God. Because there cannot be any creator if you believe in Vedanta. Because the creation itself is not there. Then who was there to create it? The entire universe is unmanifested. Brahman is unmanifested. So who created Brahman? Unanswerable question. On the more positive side, there are certain physical concepts that were identified in the various Indian philosophies. We have already talked about the Paramanu, Param Anu, that is the ultimate particle. Then there is a beautiful concept called Sanskara. Translated into English, the concept of Sanskara is almost literally, it echoes Newton's principle of inertia. It says that if a moving body, the moving body moves out of an impulse which is within it, and till that impulse is there, it will not change its course. It will not change its velocity. This is called Sanskara. This is almost akin to concept of inertia of Newton, but of course there is no mathematical proof, nothing. These are all philosophical concepts. Sanskara. The great Somarendranath Sen, in his Vigyaner Itihas, written in Bengali, he has explained this very beautifully. Then in the Vaisheshika Nyaya, we already find the concept of force. Gravitation. Gravitation, Vaisheshika Nyaya, it expounds on that, and more specifically Bhaskaracharya, the second Bhaskar, he details this principle of gravity, but he never did any experiment. He did not go for the mathematical proof. He did, as Meghnad Shah said, he did not show the orbits are elliptical. But he still, the concept of gravitation was there with the Indian, some traits of Indian philosophy. Then Skandha is very important. It is for Jainism. They define Skandha as a conglomeration of paramanus, means molecule. Skandha is a conglomeration of atoms. So it is a molecule. The most peculiar and rather difficult to understand is what is called Pudgala. Pudgala is the plasma state of matter. Why I say they did not understand what plasma matter is, but as they define the various kinds of matter, this concept comes out. I have already talked about this. I am not going to. Now, since time is less, should I read out this? I think I better skip this. Time is much less. I have quoted at length from D.P. Chattopadhyay on what is atomism and motion, the Buddhist ideas. I'm skipping this. I'm directly coming to Charvaka philosophies. Charvaka, as we know, it was actually a group. Charvaka was not one individual. As Dr. Ramakrishna Bhattacharya and before him, Devi Prasad Chattopadhyay, both of them worked on this. And they showed that they were so militantly materialist. They did not agree, or rather they opposed, very vehemently opposed the Brahminism in all its aspects, its social aspects, its philosophical aspects, the rites and rituals perpetrated by the Brahmins. They even ridiculed the Brahmins that when a child is born in a family, you have to call a Brahmin priest for the Annaprasana and other things. when that child, if it is a Brahmin child, when that child grows up, you have to call a Brahmin to conduct the Upanayana ceremony. When he marries, once again you have to call a Brahmin. And even when he dies, you have to call a Brahmin to conduct the Shraddha ceremony. So the Brahmins have arranged the entire the gamut of social rituals and the beliefs so that the Brahmins always, in all situations, they profited from it. This was categorically stated in those days, 1,500 years at least ago, by the Charvaks. So nobody loved them, that is the higher classes. And so almost all the philosophies, including the Buddhism, including Jainism, they were against them. Charvaka, also called Lokayata, it is a philosophical school of materialists who rejected the notion of afterworld, the notion of karma, moksha, liberation, the authority of the sacred scriptures, the Vedas, and the immortality of the self. They categorically denied all this. Okay. It was a very popular belief system in India before the emergence of Jainism and Buddhism. I shall conclude by detailing this wonderful concept. The Brahmins and the other idealist philosophers challenged them that if you do not believe in anything other than materials, matter, then how do you explain the mind or the soul? You cannot explain, because mind is something beyond matter. Here was the answer. They say, if you eat a bowl of molasses or a plate of rice, you do not get intoxicated, although you become sleepy, as you feel after the lunch. So, but you are not intoxicated by eating rice. But if you leave open that same bowl of molasses or a plate of rice for a few days, then, and after that you eat or drink it, you will be intoxicated. For it has now turned into wine, which can affect the working of your brain. Mind you, in those days there was no concept of fermentation, no concept of brewing, no concept of enzyme, and they were putting forth this philosophical argument. So they are putting the question, have you added any material to it from outside? Obviously you have not. Then, without the addition of any material from outside, a substance acquires a new quality called intoxication, which affects your consciousness. So it was there within the particles that constituted the rice or the molasses. Therefore, by dint of purely internal material actions of a substance, a new quality can be generated. The same holds for the soul or the mind. It is generated out of the internal bodily functions. As soon as the material body dies, that is, the actions and interactions no longer take place. The soul or mind also dies. It has no existence separate from the body. A wonderful argument in so many years ago. Even today, I think it is quite valid. Although nowadays we know why rice turns into wine. But the method of argument, basing that we do not accept anything beyond matter, but this matter itself gives rise to the mind, which is not material, which is real but not material. Can you hold the mind? Can you see the mind? Can you test it? You cannot, but still it is real. And they are saying, by their philosophical argument, not by experiments, they are saying that, so a material action and interaction can give rise to something which is immaterial, like mind, but real. So this is, I think, a wonderful piece of argument. And just as I was saying, Pudgala of Jain atomism, Pud means to combine and Gala means to dissociate. They say that the atoms have two states. The atomic or anu aggregate the skandha, two or more atoms combine to form a skandha, and Jaina atoms represent only a stage in the natural process. These are not the ultimates of gross number, and it differs very much from the Vaisheshika Paramanu. Bodha atomism, here atom is defined as in the আমার হয়ে গেছে, just 1 minute. Okay, it will be finished. Atom is indivisible, unanalyzable, invisible, inaudible, unstable, I'm sorry, there is a printing mistake there, untestable, no, it's not a printing mistake, untestable and intangible. There are two types, simple and compound, and the Buddhists say that there are 8 variants, 4 fundamental, that is solid, liquid, hot and moving, and 4 secondary, color, odor, taste, touch, and the essence of reality is motion. This is where Devi Prasad Chattopadhyay has written a wonderful tract, but there is no time to read out that. So I think I better close now. Thank you.
Thank you, Dr. Ashish Lahiri, for that very a talk which walked us through the materialistic outlooks in ancient life, and I'm sure there are many questions around, but we'll take the questions at the end after all the 3 talks are over, and I request you to keep the questions so that we'll take it up. Dr. Ashish Lahiri, went through the different forms of both theistic and atheistic philosophies, and I was quite surprised to see some of these which I had not heard of, like the Buddha atomism, and also about the gravitation reference. I'm sure these are things which have been hidden there, and I also have a question for him about the other forms which existed in non-written forms. We'll take it up at the end. And I now invite Professor Smarak Chaudhary of the Vice Chancellor of Ashoka University to give his talk and for discussion on the mathematical astronomical traditions of our country. Professor Smarak, stage is yours. Yes, 30 minutes.
I was given this mic. I don't know if this works. Does this work? Yes, I do. Thank you.
Are you going to use that?
Yeah, I'll just use this. Thank you. So I thought of talking about mathematics and astronomy, and to motivate why I talk of them together in the context of ancient India and our tradition of science. That in the previous speaker also spoke of the fact that it's often claimed that everything was there in ancient India. This is a field in which there was quite a lot that was devised in the Indian tradition. And what I'll try today to do is to motivate you the reasons behind it and the kinds of achievements that we had. I can't really talk about everything, but I thought, from my previous institution, Ayuka in Pune, I thought I'd show you at the beginning 2 images of what is there in the central courtyard. And you can see we have this amazing statue of Newton representing Western science, done in a very Indian way, sitting under a banyan tree, staring at an apple, wondering where it came from. And across the courtyard is this statue. It's not clear? I'll use this one. See. Maybe I'll stand there. Does this work? Yeah, as you see, the other statue there, which we built in the courtyard of Ayuka, is now the Wikipedia picture of Aryabhatta, because we don't know what he looked like, and is now represents Indian science. So the kind of the contrast of the two. Let's see if this works. Sorry. Does this work? Next slide, please. Can you change the slide? I don't think this works. So I think generally what we should worry about when we talk about science in the context of a civilization that has been there for thousands of years is that there are three categories in my mind of science. One can calculate, one can collect a lot of experiences, put them together and seek some causal connection between them. And this is a purely empirical collection without any motivation of a general theory governing these observations. And this often is called pseudoscience because it might feel that you're gathering a lot of evidence about something, but the causal connections are not very consistent with each other. And a lot of what we call science, as has been outlined in the entire meeting here, there will be a lot of people who will talk about phenomena that we would call new pseudoscience. However, when we talk about the tradition of Indian science, be it astronomy, be it mathematics, be it biology, we often talk about people who thought about certain ideas. We heard about the Vaisheshikas, where Kanada and others thought about the smallest particles, the Paramanu of matter, or even the idea of things falling towards the earth and calling it the theory of gravitation. These are wonderful ideas, but in my mind, these are episodes on incomplete episodes of science. What I mean by incomplete science is that you can come up with a great idea, but unless you have evidence, you can design experiments, you can actually have some evidence where it can distinguish that idea from other rival ideas, then it is very difficult to complete the cycle and establish your idea. Clever ideas, clever theoretical ideas are always fantastic, and you'll see a lot of examples of them when I talk about our traditional knowledge in mathematics, for example. But once you come to a stage where you cannot establish it, the science remains incomplete. And that is why, for example, we attribute the discovery of the concept of the atom to Dalton and people who actually did experiments to establish the existence of atoms. And before that, in doing the periodic table, talk about what kind of variation can be of different kinds of nuclei in atoms. And that is one of the reasons why ideas don't constitute science. There has to be continuity to a stage where, to quote Manmohan Singh, the time of the idea has to be right, where you actually have the technology to establish the evidence of the science. And the third is where what we call science, which has to be supported by empirical evidence, right? And the theory behind it has to make sense, and empiricism has to support it. Now, I mean, I'm not saying any of this is wrong, because in the progress of science, you can see a lot of very famous people we revere as scientists, do such things. I just give an example of how in Isaac Newton all three types of science were there. Newton spent 12 years of his life doing alchemy, which we think is complete pseudoscience, right? He tried to convert mercury into gold. He spent almost 8 years of his life writing a thick 800-page book on analyzing the scientific aspects of the Bible, and came to the conclusion that the earth is 4,000 years old. That is completely pseudoscience, right? There was no scientific basis of it. And yet, the same person had a theory of light, which I would call incomplete science, because there was no experiment following it up, but it had wonderful ideas that only now we can figure out how good it was. And then, of course, he did empirical science, where the law of gravitation he applied to explain Kepler's laws, the elliptical orbits. He actually brought together the mathematical concepts, etc., and he actually did experiments on it. So all these different kinds of science can come together in various parts of the history of science. And when one says that, of course, in this tradition we had this particular kind of science, you have to understand what context it is in. And that is one of the things I want to know. So why do we talk about astronomy and mathematics in this context? And that is, astronomy if you're talking of ancient India, we say talk about 2000 years to 1000 years ago, astronomy becomes a very important part of one's life, and that is because for doing all of these things, for navigation, for knowing what the calendar looks like, or when to sow your crop, and when to harvest it, when the important festivals will come, and all this stuff, along with, of course, the pseudoscience of astrology. All of this is motivated by you wanting to know about astronomy, wanting to know a little bit more about the sky, and as a result, you had to develop the mathematics to do it. And this is why no coincidence that in all traditional syllabuses of universities, be it in Nalanda and Takshashila, the basic subjects of the basic subjects taught, you would have astronomy and mathematics. If you ask the question what was taught in Nalanda, these were the two basic subjects. If you ask what did Newton learn in Cambridge in the 17th century, you will find that of the 5 or 6 subjects that he had to learn at university, mathematics and astronomy are two of the major subjects. And this is because it relates to our life. I took this from one of my colleague Mayank Vahyar's talks, which I think is very interesting, because Varahamihira defines what an astronomer is. And here shows how to actually, what you mean by an astronomer. Nowadays, when you talk about astronomy, it's probably very different from what an astronomer represents science and a very mathematical aspect of science. And you can see that these are all the things that you are expected to do. You are expected to understand the calendar, and you're expected to predict when certain periods will come where you can have your festivals, solstices, eclipses, and things like that. And so the nakshatras and stuff like that you have to calculate. So let me just go into a little bit detail on why these are so complicated. We know that the sun goes around the earth, and of course in this particular system everybody thinks that the earth is in the center and the sun goes around the earth, and you can see the sky turning around us. So you can see that there is a path in the sky in which the sun goes, right? We now know the sun is in the center and the earth is going around it, but all the planets also go around in the same plane, right? Because the solar system has a plane. And as a result, when you look at the sky, when you see the sun go around across the sky, you also see the planets follow the same path. And Indian philosophers and scientists had picked this up and thought that this would be a very, very important path in the sky, right? And so a lot of Indian tradition of mathematics and astronomy is based on that path, which is called the ecliptic. That becomes very, very important. And this is true of the Southern European and Middle Eastern astronomers as well. Of course, these traditions were connected at that time. As opposed to, you can see other astronomies in the world. For example, Chinese astronomy actually describes the whole sky in great detail. They pay attention to the whole sky. The Indian tradition pays attention mostly to the ecliptic. And that is why what you do is you take the Earth's orbit, the sun's orbit in the sky, and because all the planets also go, and divide it up into 12 houses. You call them the signs of the zodiac, and these are the signs of the zodiac. And so you can see as the Earth goes around the sun, you can see the sun is in some house, and you divide it up into each month is then governed by a house of the zodiac, and that you have to understand when the sun is going to come into this house, which are essentially the 12 parts of the ecliptic, and this requires mathematics. Then you further complicate it by you have the 27 nakshatras, which are also the star patterns that are around the same ecliptic, right? You divide it up into 27 different houses. Actually, in some cases, even Avijit comes in, so 28. Now, so if the sun goes around the earth in 360 degrees in a year, so each of these 27 nakshatras would then have a period of about 13 degrees, which is 360 divided by 27. And so that defines one part of a particular part of this ecliptic, right? So when you're trying to find some instances of time, for example, you were born at a certain time, so you find where the sun is or where the moon is, in which house of the zodiac or in front of which nakshatra, you have to calculate that, right? Or actually, the lunar month, which is kind of 29.5 days, is divided up into 30 different parts called tithis, and these tithis then correspond to about 12 degrees. So either you have the 13-degree division or the 12-degree division. It depends on different traditions of astrology or astronomy. You have to actually find mathematical ways of finding how and when the sun is going to be there all through the year. And this kind of mathematics requires a lot of, this kind of calculation requires a lot of mathematics to be developed. And if you want to build a calendar system, a panchang, based on it, then it is not trivial. And this the Indian tradition had. The Indian tradition, because of its requirements from astrology and also the tradition of festivals being held on certain days of the year, the prediction of these were very, very important. So you can see that, you define your day and your month. The month is defined in terms of the orbit of the moon around the earth. The year is the orbit of the sun around the earth, or now we say the earth around the sun. And sorry, let me just go to the next one. The thing is, if you take the time it takes for the earth to go around the sun, it is 365.24 days, right? You can see these are not whole numbers. And then you have the moon going around the earth is 29.53 days. It's not a whole number. And these ratios are not very simple numbers. And as a result, it is very difficult to say, for example, there are 12 months in the year, or there are 30 days in a month, because you have to play with the fractions. If you don't, then you go out of step. And that is why suddenly the festival that you're used to seeing in the summer becomes in the winter and things like that, right? And so this is very important. And the basic problem was that these ratios are not integers. And very early on, as early as the Surya Siddhanta in the 4th century, 5th century, in the Brahmini's tradition, these calendars were developed. So we have the solar calendar, and so you see all the traditions all across India. And you can see the Tamil calendar, the Bengali calendar follow a tradition of the solar based on the sun's orbit. Then, of course, you have the purely lunar calendars, which are based on the phases of the moon. But the problem is, of course, there is this mismatch between the size of the month and the time that it goes around, the moon goes around the earth. And that's the Islamic calendar. And then you can put the two together, which started from the Surya Siddhanta, and now, of course, is standardized in the Indian calendar, which combines the lunar calendar, the solar calendar. And in order to make sure that they all match up, because those integers, those fractions are not whole numbers, what you have to do is you have to sometimes add a month in between, right? And these are, so you have to do this roughly once in 3 years, because if you look at the different kind of mismatches between them, these fractions work out such that if you put an extra month every 3 years, actually it's more than that. People then figured out that if you look at, you need 7 extra months in 19 years. This was all worked out in Surya Siddhanta. And so we have our calendars which follow this Adhik Mas idea, where you put an extra month in there, right? And this is done differently in different calendars. And the ones we follow now actually have this Adhik Mas in there. The Gregorian calendar, that doesn't happen, but they do it in a different way. So if you look at, I think the tradition of Indian mathematics with astronomy was motivated by by this idea that we have to understand what is happening in the sky, and we have to predict things so that we can, essentially define the events of the year. And of course, there was the astrological motivation. A lot of these people, even in the medieval ages, if you're looking at Kepler and people like that, Copernicus, they were astrologers. They believed in astrology. But that motivated them to develop the mathematics for astronomy. And this is happening in the case of Aryabhatta. So Aryabhatta, working in the 6th century, very clearly knew that the source of light in the solar system is the sun. And everybody, including the moon and the planets, they have reflected light. So this kind of awareness is already there. However, the question of how the sun produces that light is not resolved until the 20th century, right? But the awareness that is there. And then, as a result, by looking at the different relative positions, Aryabhatta was able to figure out a system of transits, eclipses, etc., and what kind of geometrical positions would be needed. This has now, of course, been standardized. The calendar I'm talking about in Meghnad Saha, the Saha Committee calendar, which is the national calendar, which actually takes into account a lot of these things. The fact that we know that the sun's speed is not the same in the orbit around the Earth, or the Earth's orbit around the sun, from Kepler's laws, etc. That comes in to a much more modern analysis of the calendar, which a lot of it was addressed in the tradition, Indian tradition, because people actually could measure the fact that the sun is going around at a different varying speed, and that adds to the quantification of the calendar. So, going from antiquity, we are talking of the megalithic era, you can see all these amazing monuments that were built. In England, you find, in the UK, you find all the henges, the stone henges, etc. In India, there are at least 3,000 megalithic structures that we know of, from 3000 BCE up to the post-Christian era. And they're all, for example, in southern India. And these were essentially based to start making measurements of the position of the sun on a certain day, the place of the sunrise, and things that contribute to our understanding of the calendar. So that tradition was already there of building these mega things. And astronomy plays an important part right from the Vedas, where of course the idea of the difference between the lunar and solar months was already there. I would concentrate on some of these systems that we hear all about, and try to figure out what they were trying to do, and whether their contribution to science as a whole that we know is as important as it is often thought to be. And the answer is yes. There is so much to be proud of in the tradition of Indian mathematics and astronomy. I think we tend to focus on some of the wrong areas, which we try to not see in the context. You think of, as I said, Aryabhatta knew that the sun has its own light, and then understood that the eclipses were shadows. This is something Plato and Aristotle are talking about in the Greek system 500 years before that, but Aryabhatta's ideas actually lead him to actually try to mathematically calculate and try to predict when the eclipses will happen. He also tries to find out what certain the various periods of time will be in terms of the orbit of the sun and the moon. He wrote a whole book called Kalakriya, in which he tried to make sense of the different systems of time that exists in the Indian tradition till then, of the yugas and the various and in terms of the sun and the moon. And he does a lot of it. Gola, for example, is an amazing book in which actually talks about the way the shadow the moon and the sun propagate in the solar system, right? We often think of the Rahu and Ketu idea of mythology and point to it and say, look, I mean, we had these very primitive ways of thinking about eclipses, and Aryabhatta had worked it out in terms of shadows, right? So if you look at the actual tradition of people who were working on the mathematics of it, this was already there. Of the various students and followers of Aryabhatta, who suppose in northern India, comes Bhaskara, who is in central India. And Bhaskara, of course, is writing, Bhaskara is collecting a lot of mathematics. And this is another thing that's important. When you look at one mathematician, does their work get into the teaching at Dunnett schools and universities, right? And there are some people like Varahamira, who is actually a librarian, who collected together a lot of mathematics and made it into books, which are encyclopedias. Similarly, Bhaskara did that. Bhaskara collected what we now call algebra, Bija Ganita, things like that, and got them together in terms of verses and compiled them. And he was a great outreach person, popularizer, right? And so he's doing this and also he's teaching. Of course, I want to talk about the second Bhaskara, who's also often confused with the first Bhaskara, who comes a lot later, right? 12th century. And here he's the most important popularizer, because he writes the book that is, I think, most important from this period, which actually made mathematics very popular, and that's Lilavati. And Lilavati is, of course, named after his daughter, who also becomes a mathematician. But the actual puzzles of Lilavati, which are arithmetic puzzles, became so popular, it became an educational tool. There are many of these little puzzles from Lilavati that we have encountered in school in other guises, in our Patiganit books, right? But the second Bhaskara actually by that time had worked out very, very accurate ways of calculating eclipses and rising, setting of planets, etc. So this whole period is called Siddhantic astronomy. So Siddhantic astronomy starts with Aryabhatta and follows the tradition of the two Bhaskaras and their students. And so there are, if you go in and look at how, for example, Aryabhatta's work was then interpreted by his students in a set of books that took Aryabhatta's work and then analyzed it, you will see that there are very long traditions that are being developed within a few decades or even a century or two. The question is, in school, when we study geometry, we study from Euclid, right? We don't study from the work that these people had done. And that is because I think these traditions of single famous mathematicians or scientists actually grew to become a corpus of work which stayed very much within that tradition and was not propagated to the rest of the country. And we can go and look at what we study in geometry or arithmetic in school. In there, many of those elements are in there. And Aryabhatta students would have written quite a lot of books on what Aryabhatta had done, but that hasn't propagated to us as a continuous tradition. So I'm winding down. What I wanted to say is, in this tradition, I want to give you one example of somebody who actually stood out in the crowd, and that is Madhava. In Madhava's school of the Kerala school in near Thrissur, essentially, he had developed a very amazing way of calculating series, calculating the sums of series algebraically. Now, if you go back to the Shalabha Sutras, which is in the Indian tradition of thousands of years, 2000 years, there are certain series that were developed in order to take irrational numbers like square root of 2 or something like that and evaluate that in the form of a series which are essentially fractions and adding them together. This tradition was already there. What Madhava did was, very interestingly, developed it into a system of mathematics that was absolutely necessary in order to calculate the tithis and the nakshatras and when the sun will be in any of these quarters. And this is very important because it comes as, because the sun and the moon, etc., they vary in their speeds as they go around the earth. And in order to do that, he developed a system which we now can call calculus. And this is why you hear that Madhava invented calculus. It comes from the fact that he invented a couple of systems which were essentially, can be interpreted now as some things that are derivatives of trigonometric functions, which are very much like differential calculus. But very importantly, what he did was this. Essentially, you know, if you take the 1/4 of a circle and you find its area, and if the circle's radius is 1, then that becomes essentially pi by 4, 1/4 of pi. And a lot of people have been trying to figure out how from the square as it is there to find out the area of the circle, that 1/4 of a quadrant of a circle. This is how Leibniz actually invented integral calculus much later on, where he had this series which you can see here. He invented that series. The interesting thing is Madhava invented that series too. And in Madhava's work, which is around 1400 AD or CE, he had a very, very simple geometric way of finding the area under that curve and picked up this thing, and you can see paridhi, which is the circumference essentially, and which is, and he writes, it's of course twice the vyasa, which is the vyasa is the diameter of a circle, and so you know that the circumference is 2 pi r, so he calculates the value of pi, and as a result he invents integral calculus to some extent, because he calculates the value of pi by finding the area under that curve, which is the circular curve, right? So you can see what he's trying to do is not wanted to point out one more thing. That is, okay, let me hold this like this. I only had 1 more minute to say. There is a question that comes up in much of this discussion. When you're talking of science, can there be an Indian science? Science is universal, right? So when you're talking about Fourier series, right? When you talk about Fourier series, can Fourier series be Indian? When you're talking about the law of gravitation, is that Indian science? Because science does not work differently in India. What we can do in trying to establish how we contribute of the world is to figure out how science works now. And you can see that science has become a global enterprise right now, in which the entire scientific world across the world, they collaborate to establish the empirical establishment of theories, of ideas, and things like that. And you can find out, for example, whether we can develop technologies within countries, like ISRO does for cheap space technologies, or when we were isolated from the world, we invented our own computer called Param, and things like that. We can do that. However, I think it is very difficult to be parochial in science. And here is an opportunity for us to be very global.
to be very, to work with the rest of the world in order to advance knowledge as a whole. And when we look back at ancient Indian traditions, it is okay because we are looking back at a world when the world was not connected and India was not as connected to the rest of the world as it is now. And then if we see that in the context of modern Indian science, I think it is more important to focus on what modern India can give to the world of astronomy, mathematics, and other sciences than to look at what we did contribute 2,000 years ago. I'll stop there and I will come back in discussions.
Why the mic is not on? So, thank you, Professor Smarak Vigyan Mela, and he's walked us through 1,000 years of our overall mathematical parts and the astronomy that existed from Aryabhatta to Madhava, and then he's also had a very nice conclusion about what actually is meant by indigenization, should be meant by indigenization of science and technology, and that's been a fascinating thing, saying that what you need to look at is in various other aspects like anthropology, psychology, and also looking at how paradigm shifts can be transferred between cultures. So unfortunately we can't hear him further on these aspects, maybe, but they can come up with the questions in the discussion that follows. So I wish to thank you, Professor Smarak, again, and I would like to invite Dr. Gauri Hawal, formerly head Department of Zoology in Pune, to talk to us about biological and medicinal science in ancient India. Thank you. Dr. Gauri.
Hello. Okay, good afternoon all of you. Now this is my first talk for All India People Science Congress, and I hope you will, yes, I hope you will like what I want to say about the biology and with reference to ancient Indian knowledge. Next slide. Okay, so now for New Education Policy 2020, this subject was made compulsory as ancient Indian knowledge systems. And all the autonomous colleges, they have implemented new education policy from academic year 23-24, at least in Pune city. And then
You can change towards screen also.
okay. So the topic of ancient science is debatable issue even from the historical point, as much of the progress in scientific thought is modern. So the focal point of the debate should be to what extent we can call the ancient knowledge as scientific knowledge. Okay, so for biological sciences or even for the life, we have to situate the discussion in historical context, in context of modern theory of evolution. It is necessary to understand the formation of Indian subcontinent. The formation of the Indian subcontinent was understood through the theory of continental drift. Now this theory was initially proposed by Alfred Wegener in early 20th century. So we have to start with the modern science and then we can go back to our ancient history. So Wegener suggested that Earth's continents were once joined as a single sub-supercontinent, and that he called it as Pangea. Over the time,
this Pangea broke and the continents they drifted apart. So although Wegener's theory was groundbreaking, it was eventually replaced by plate tectonics, and it provides a much more detailed explanation of how the Earth's lithosphere plates they move. So 240 million years ago, it was Pangea where all the continents were part of giant landmass. And then 200 million years ago, this Pangea, it started breaking away. Can I have the video, please? Video. So you can see over here how the landmass was there in, so this landmass is changing continuously over the millions of years. And you can see where the India was located. There were two major continents, one was Laurasia and another one was Gondwanas. Gondwana also separated, fragmented over the millions of years, and there was Tethys Ocean, but then Indian subcontinent, it moved towards the Eurasia, it got attached to the Eurasia, formation of the Himalayan has taken place. So this geographical position of, okay, you can go to the slides back. So this process of plate movements over millions of years, it has shaped the current geography of Indian subcontinent. And the major event being the formation of the Himalayas. After that, we will move towards the evolution of the humans, or from where the humans they arrived in India. So you can see Homo sapiens, they believed to emerge in Africa around 300,000 years ago, and they have migrated from, there were three species of Homos, Homo sapiens, and the one which we know is, so we are Homo sapiens. Before us, there were Homo erectus, and Homo erectus, they were the first one to migrate to India. Later on, their place was taken up by the Homo sapiens. So 65,000 years ago, modern humans or Homo sapiens, they are first believed to have arrived in India. For that, there is evidence of stone tools which were found in the ashes of Jwalapuram in Andhra Pradesh. Then there were also early human fossils that were found in Narmada Valley. About 75,000 years ago, the sapiens, they were leaving Africa. Just around this time, there was a major catastrophe that has happened across the Indian Ocean in the North Sumatra, in a volcanic island which is called as Toba. This region has been restless for over 2 million years. The most violent volcanic eruption exploded Toba, and the Toba explosion created a great disequilibrium in global climate. Sapiens were still at the margins of the Africa, but those erectors who were in India, they were directly harmed. And the damage was such that the erectors, they have died and they got extinct. But then their place was taken up by the sapiens. Along with that, this Toba's ash blanketed the eastern and central India. A strong westward wind carried grey-white volcanic ash high into the sky, and it smothered the forest of India. Some studies, they also show that this event was an important reason even today why there are no luxuriant forests in these regions like eastern Andhra Pradesh and northeastern Tamil Nadu. One such study also suggests that Toba event is the only reason for absence of large mammals like tigers, elephants and even langurs in these specific areas. So this Toba event has made the life very difficult for the Homo erectus, and the climate change diminished the population of erectus, and it has never recovered after that, and their place is taken up by the Homo sapiens. So there is again difference in the migration pre-Toba event and post-Toba event. Pre-Toba, we can find the stone tools below the Toba's ash, and that has said that humans must have migrated before the Toba event. Post-Toba migration, probably the humans, they have taken the sea routes and they have moved from the coast of Arabia and Persia, eventually reaching India, which is one of the major settling points for the humans. Okay. So then, till that time, the humans, they were the hunter-gatherers. And from their nomadic lifestyle, they started to settle, and that period is called as the settled life, where major change has taken place in the human life, and it has this is because of the development of the agriculture and domestication of plants and animals. So from hunter-gatherers to nomadic style, humans, they started settling, and one of the example of this is Indus Valley civilization, and you can see here in the excavation the sites they have found in Balochistan, which is now in the Pakistan. So the semi-nomadic people, they started farming in this region. Mehergarh is another site where also you can find such settlements. So sedentariness and the Indus Valley civilization, because of sedentariness, Indus Valley civilization has taken place, and that has resulted in the gaining knowledge about biology. So 7000 before Common Era, communities in South Asia began transition to sedentary life, investing more labor in land preparation and agricultural practices. So this starts the beginning of the settled life. So 4500 before Common Era, Indus Valley civilization start evolving, which flourished from 2600 BCE to 1900 BCE, and again the remnants can be seen in the present day Pakistan. In India, we have the site in Gujarat, which we call it as Lothal. There also you will find the remnants of the Indus Valley civilization. These early agricultural practices included domesticating of animals such as sheep, goats, pigs, oxen, etc., and the cultivation of grain producing plants. So this shift represents the early use of biology for human benefit. Two important significant characters, you can say, who have played role in the ancient Indian knowledge, that is Charak and Sushruta. Charak was an ancient Indian physician and scholar who made significant contributions to field of Ayurveda. He is considered one of the principal contributors of Charak Samhita. He has written 8 volumes and 128 chapters of Charak Samhita, which was written around 2500 years ago. So it is a mix of Ayurveda and spiritual concept, but his approach towards medicine was holistic and focused on understanding the body as a whole. So he emphasized the importance of maintaining the balance between these 3 doshas, Vata, Pitta and Kapha, and believed that disease resulted from an imbalance in these Vata, Pitta and Kapha. So his treatments included to restore the balance. He also said that Yatha Visham Yatha Shastram Yatha Agni Ashani Yatha Tatha Aushadam Avidnyatam Vidnyatam Amruta Yatha. So without knowledge, if you use any of these, they will be poison. But with knowledge, the poison can also become the Amrut. So knowledge is very important. Then another one was Sushruta. He was ancient surgeon from around 6th century, and he was known for his pioneering surgical techniques, and his influential text is Sushrut Samhita. which is the key source of knowledge about surgery in ancient India. So he viewed surgery as Shalya Tantra, which is a broad and important field. There are the written documents about his groundbreaking surgeries such as rhinoplasty. I think during that social system there was a system of cutting the nose to give the punishment. So for that he developed this rhinoplasty, which is rebuilding the nose, removing the dead fetus, and lithotomy, cutting the bladder to remove the stones. He also created innovative methods for dissecting human body to study the structure. Sushruta Samhita is based on scientific methods similar to those in Charak Samhita, which emphasizes the use of experience and reason. These are the tools which Sushruta used for his surgery. Now with the invention of, you can say, medicine, Charak and Sushruta, they have also studied different life forms and they have classified them into immobile and mobile. So immobile are the plants and the mobile are the animals and humans. So they are not considering humans as one of the animals. So humans are always separate. So most important fundamental step in any scientific inquiry is classification. And in ancient texts, animals were classified based on various criteria which can help in understanding the biological knowledge. So in Dharma Sutras and other texts, classification was based on these characters, like body characters, which will include feet, teeth, nails, etc. Habitat where these animals they are living. So the classification was only whether they are village animals or they are forest dwelling animals, and which are the animals which are fit for consumption. So the knowledge was based on only these criteria, which is again very much human centric. Birds were categorized based on their food habits, leg types and the beak color. Another method of classification that was used, or in this text it is written about the sex differentiation. So in Rig Veda, sex differentiation is very clear, where particularly for the cattle, where Go is for the cow and Vrusha is for the bull. But this differentiation was not always consistent for all the species. Then there was confusion in the naming of the animals. For now, for the modern science, we use binomial nomenclature. But such kind of nomenclature was not observed in these ancient systems. So term Mruga is used for deer and specifically for spotted deer. This shows that while there was substantial knowledge about animals, it did not always conform the precise scientific classification that we use. So same thing has happened for the rhinoceros also. Different texts will have different names for rhino. Question about the rhinoceros. So detailed investigation into the etymology and usage of these terms across different periods and texts, it needs to be analyzed properly, and then it can be included in the syllabus for Indian knowledge systems. The biological diversity is also recognized by ancient Indians. So in Apastamba Dharma Sutra, there is a list of names of the animals. Then there are some of the texts, they also provide animal classification. Charak Sanhita categorizes animals into 8 groups. Bruhan Samhita, Varaha Mihira offers further description about the fauna. Purana, including Bhagavad Puran, mention variety of animals. Mruga Pakshi Shastra provides extensive list of animals. Additionally, a study by Sen Sharma on the Gautam Sanhita highlights that while the text contains some references of plants and the animals, the number is small compared what is known from archaeological findings. So there are a lot of places where the archaeological studies are going on, the excavations are going on, and from the bones that were collected from these sites, and if you compare the number of different types of bones that have been collected, their number and the number which is mentioned in this text, it does not match. So these records suggest that ancient people, they used wider range of animals, but it is not there in their texts. So this gap points a lack of awareness about the extinct animals or evolutionary theory in ancient Indian thought. So there is another Mesolithic site in Pratapgarh district. The fauna spectrum of Damdama indicate a wide range of animals being exploited by humans for different uses, for tool making as well as for food. So it did not reveal bones of any domestic animals among thousands of bone fragments. The fauna comprised wide spectrum of mammals as large as elephant and as small as pygmy hawk. The faunal exploitation indicates a cyclical trend in resource management. So humans, they were also managing the animal resource for their benefit. So if mammals are less, they used birds for the food. So there was again cyclical trend in the resource management. Now the story is different for the plants. There was a transmission of knowledge through oral tradition. So earlier societies, they passed their knowledge about plants orally and based on the empirical observations. This knowledge included the use of plants for various purposes such as food, shelter, poison, medicines and ceremonies or rituals. The plant classification in ancient text where in Sushruta Sanhita, it is based on parts use, taste, dietary effects. While Sushruta Sanhita doesn't provide detailed botanical descriptions, but it demonstrates the close observation of some of the plants such as sugarcane and listing fungi and their growth medium, whether they are growing on the soil or in the wood. Charak Sanhita, it has further classified the plants again based on the habitat where the plants they are growing, whether they are domesticated, that means whether they are growing in the field or they are in the forest. Then whether the flowers and fruits they are present and what is the type of reproduction in these plants, whether it is through seeds or through the spores. So there was understanding of plant biology, but though it is not in the modern scientific terms. The plants, they were further classified into without fruiting, without flowering, flowering and fruiting both, the grass varieties and also the food plants, so which were cultivated for consumption, including grains, vegetables and the fruits. So the knowledge based of the parts based on observation and practical use rather than formal scientific classification system. This knowledge of plant formed the basis of Ayurvedic and traditional healing systems, highlighting the importance in ancient society. The Sushrut Samhita mentions medicinal herb and plants should be recognized and identified with the help of cowherds, hermits, huntsmen, forest dwellers, and those who select the fruits and edible roots of the forest. So physician, who is the main or active herb collector himself, he should acquire the knowledge of soil science as well, because soil gives taste, color to the plants. Early medicine and Ayurveda in ancient India. So Ayurveda is actually the knowledge of life. Unlike other fields like botany and the zoology, Ayurveda holds significant scientific potential, particularly in understanding the relationship between human being and nature. So there are theoretical foundations for the Ayurveda, where there is interaction between environmental matter and the body matter. The data, the ancient physicians, they have compiled the vast empirical data on the effects of foods, drinks, and other subjects on the human, other substances on the human health. Then phenomenon of life using the prana and the bhuta, where that term is also used, where they have considered 5 bhutas, which we call them as Pancha Mahabhutas. These Pancha Mahabhutas, they also, these 5 elements, they transform during embryonic development and continue to shape the human body. So like Akasha, Vayu, Agni, Jala, Prithvi, all these 5 elements, they are transforming the embryo to form the human body. The physicians, they emphasize that man and nature, they are fundamentally united. Unity of matter. So according to Charak Samhita, all substances in nature are interrelated and interdependent. There is nothing in nature that is irrelevant to medicine. So, Anaushadhi bhutam jagati kinchit dravyam asti. So, there is nothing that is not important or substance without relevance to medicine. So, this idea is again repeated in Charak and Sushruta. Then there is role of Agni and also life and food. So all these are connected. The nature and human, they are connected with each other. So it is impossible to ignore the significance of a number of theoretical achievements of ancient physicians. They have played a great role in collecting the data of the plants, which are the medicinal plants, how they can be used. All these data and the actual physicians, they have treated the people and their data. So it is actually the empirical data was there with these physicians. So evidently there is also something must have happened in ancient India which has inhibited or injured the science and wanting even to destroy what is once achieved by it. So the literature studies, they show that lawgivers show disrespect for doctors. So the text highlights an ancient cultural and legal perspective that considers doctors and certain other professionals as inherently impure. This impurity is so severe that even their presence is said to pollute a space. The food they offer is considered as unclean. Even the food offered to them highly becomes tainted. So this was the conception with the lawgivers. Various law codes from ancient Indian texts such as Apastamba, Gautama, Vasishtha contain rules about who can and cannot offer food to others, with doctors being repeatedly mentioned as impure. Manusmriti, an influential text in ancient Indian law and social structure, also supports this view. So it prohibits members of higher caste from accepting food from physicians, reflecting the broader cultural attitude towards them. So to conclude, in ancient India, there was a complex view of purity and social rules, where medical practitioners despite their essential role in society, were considered ritually unclean. And this belief, rooted in caste and religious norms, led to a lack of respect for doctors and their work. As a result, it contributed to decline of Ayurveda and other sciences also. Thank you. So these are the references I have used for this talk.
Thank you, Dr. Gauri Hawal, for that excellent exposition, starting from 3 lakh years ago, bringing us to about 2,600 years ago, and then showing how the social fabric which emerged around that time led to the decline of sciences and the Ayurveda that happened, and showing how the caste system and the Manusmriti especially were major inhibitors in the process. So, and she has gone not only over the geological but also the biological aspects of various sciences. And so now, thanks to the 3 speakers for the time consciousness that we are having some time, good time for discussions. Before we start the discussion, I would request Dr. Ashish Lahiri to join us on the stage. Dr. Ashish Lahiri. Dr. Ashish Lahiri, please join us on the stage so that we can start taking questions. You around? No. Okay. So I'm sure he'll join us in some time. So let's, we have, I mean, questions across the broad spectrum that has been covered. No, I think the speakers did an excellent job of showing how the materialistic philosophies came on to the, the mathematical aspects of astronomy and others, which grew from the daily needs of human beings, and then came on to how this setup emerged in India, from the earlier, from starting from Pangaea right down to the human migration, for which there is genetic and geological evidence, and ending with the problems that arose, which sort of led to the decline, and also the, as what Dr. Somak also mentioned, the small closed area in which the mathematical astronomy operated, which didn't allow this larger expansion which happened in other places like the Greek or the Arabian systems. So I'm sure there are a lot of questions. You can just put up your hand, come over to the thing and come over. Please come over. Just for the sake of the record in which going on, it would be nice if you can just introduce yourself, from which state and name, and then go on. Yeah. Please. Yeah. No, I think this gentleman wanted thing.
Sir, we became happy to see the history of science, etc., medicine. May I ask one question?
Yes, please go ahead.
Sir, in our countryside, we are being failed to communicate scientific temper. As for example, before death, relatives do not come to us, but after death, relatives come and they show they instruct us both to rule with different rules. All these rules after death, which in our Hindu community are being followed. Is there any indication in all Shastras? Number 1. Number 2, Brahmins prepare different fordosh. Fordosh means what we have to purchase from market while celebrating different rules. Is there any indication in any old Shastras? বাংলায় বলছি বোঝানোর সুবিধার জন্য, ওই যে মৃত্যুর পরে অনেক কিছু আমরা করি, রুলস ফলো করি, এগুলো কি কোনো শাস্ত্রে আছে? আর দ্বিতীয়ত হচ্ছে যে কোনো অনুষ্ঠান করতে গেলে ব্রাহ্মণরা অনেক ফর্দ তৈরি করে দেয়, সেই ফর্দটা তার
I just request Arunabh Mishra to take. I don't understand Bengali, and I think I request also the questions are kept short, so others can also take part. Yeah.
we request all, सबको ये आवेदन है हम लोग को कि अब हमारा स्पीकर ने जो ही आइटम पर बात उठाया उसके ऊपर आपका क्वेश्चन रखना, सीमायित रखना, to ask question only on the issues on which the speakers deliberated, please. Other discussions will be in the workshops, okay? For all other discussion, the workshops are there, 2 workshops are there in seminar room, ground floor, VCI auditorium, and in the first floor from 3 p.m. And all the speakers are present here. They are different set of speakers. So the questions can be put there, all other questions. But here only on the topic on which our speakers deliberated. Please, you.
To keep it short, I am forwarding my question to you. Please take it.
You can write your question.
Hello. Myself Rituparna Goswami, I represent Ilura Vigyan Mela, Assam. My question is to Professor Smarak Vigyan, and I want to ask, at present lower Earth orbit satellite race is going on in the world, and it is mainly by Elon Musk, Starlink, and also by 10 other countries, namely China, Brazil, Romania, Argentina, Chile, UK, Spain, Philippines, Malaysia, and Thailand. Now my question is, what are the implications of LEO satellites in the field of astronomical study, research, and observation? And also I want to ask that, do you think that India should also launch this satellite?
So this is not really topical. I mean, I can probably talk to you during lunch about this. Of course, this is very close to my heart, this topic. But let us stick to what I spoke about, which is the ancient Indian tradition. Musk does not play any role in ancient Indian tradition. We'll talk about Musk later. Anybody else?
Hello, I am Dr. Y.K. Sona from Chhattisgarh. I have a question from Dr. Gauri. Thank you very much, Dr. Gauri. You had a very nice presentation. At one point, you explained that the ancient people knew about the poisonous plants.
Yes.
I'm a little bit curious where they used these plants for and how they saved their human population from these poisonous plants. And is there any evidence of those avenues where they use these plants for, maybe for hunting, maybe for fishing? Is there any evidence of this poisonous, how they knew that these are the poisonous plants?
Yeah,
I have a question.
in Charak Samhita and also in Sushruta Samhita, they have made a list of the plants, and I think the physicians, they have done lot of trial and error experiments that time, because they have lot of empirical data about all these things. And they do mention that, they also say that food in large quantity becomes poison. So this concept of poison was there with them. They have specifically not mentioned which plant is poison, but they knew the concept of poison. So anything in large quantities become poison. That was their concept.
Please, just.
This is a question to Professor Sonak Rai Chaudhary. The period of mathematics and astronomy that you have covered includes the medieval period, roughly, let's say, between the 10th century to the 17th century, right? Now this was a period when there was also development of mathematics and astronomy in other parts of the world, including West Asia, China. So is there evidence of an exchange of ideas between all these different developments of mathematics and astronomy in different parts of the world? And what was the kind of interchange between, let's say, the Kerala school and these other, developments?
It's a very, very interesting question. Of course, it's a very, very active subject now of research. It is very clear that starting from about 2000 years ago, about 2500 years ago, there were trade routes that connected southern Europe and the Middle East, Iran particularly, and India. And these trade routes brought a lot of information back and forth. So when we look at, for example, I showed you the way the sun's orbit is broken up into signs of zodiac. It is very clear that that system of zodiac is used in ancient Greece, used basically in Iran, and basically in India. It's the same name. Well, they call it, Libra, we call it Tula, things like that. So it's the same thing. There is no reason why you would connect random dots in the sky and make up the same things. The other thing also we know is that you know about the precession of the equinoxes, and as a result, the fact that this astrology is based on the fact that the sun is in Aries on the vernal equinox, that has moved by at least one of those houses. Sun is in Aquarius now, not in Aries. That helps us time when this system of astrology or zodiac started. And actually, because the Earth's precession is 26,000 years, the whole movement by one house means that it is more than 2,000 years ago that this system of nomenclature started. So it is very clear that India and southern Europe, ancient Greece and Rome, were in contact. We can see that also in trades in food and food materials, etc. Now, more importantly, during the medieval period, when Europe went into an intellectual decline in terms of no new ideas were coming out, religion was very dominant, and as a result, thinkers in science were suppressed. At that time, there was quite a lot going on in China and going on in India. The entire Madhava school, Kerala school, happened at a time when Europe was producing nothing, right? And so this is a very interesting part of history, in which we know travelers, very famous travelers, were coming from China into India, coming from Western Europe in India, and exchange was happening through people who wrote down these things, wrote down what they found in India and things like that. The nature of exchange seemed to have changed. This picked up much later, of course. Picked up much later, 17th, 18th century, there was quite a lot of intellectual contact. But during the period you're talking about, when Madhava was working, and Bhaskara too, this was 13th, 14th century, it doesn't seem that their work was actually recognized very well or communicated to the rest of the world. And I'm no historian, I do not know why. The fact that 2,000 years ago there was so much intellectual exchange, and in the medieval part there wasn't, is a very interesting point. Thanks.
Thank you, Professor Vela. Any other questions? Okay, so I think we will also be meeting at the workshop in the afternoon. That's going to be one in Hall 3 on Calcutta Declaration about the scientific temper, and another one on the room 1, VCI meeting room, about women in science and the Indian perspective. The three speakers here, Ashish Lahiri, Professor Somak and Dr. Gauri have walked us through the entire spectrum of the Indian knowledge system, showing what actually is there, and by implication what is also not there, and thereby showing how the current thrust of the Indian knowledge system that is being pushed through the NEP is actually focusing on what is not there, and what is actually there is being completely left out. We know why, because what is actually there shows a materialistic outlook on life, and shows that human beings are human beings who live daily lives, and therefore the science develops through their interactions and not by some divine thing that is thrust upon us. So I think the speakers have done a wonderful job for us, and really would like to thank the speakers again on behalf of AIPSN, on your behalf also, and I do join us all in the workshop again. And so just before concluding the session, I would like to make two announcements on behalf of AIPSN. One is that AIPSN is bringing out a newsletter in English and Hindi called People Science in English and Jan Vigyan Samachar in Hindi. These two newsletters, we are circulating a poll in WhatsApp through your states, and I think you would please try to get hold of the poll, click on the Google form and go through the questions and submit. It will help us make the newsletters better and how it can reach you better. And the other thing is, we have also have, if you walk around, you will see, thanks to the organizing committee, AIPSN, they put up posters having 4 QR codes, right? These 4 QR codes, one gives you the social handle of Facebook, the other gives you the social handle of YouTube of AIPSN, the third gives you the Instagram handle of AIPSN, and the fourth gives you the Twitter handle of AIPSN. Do scan them, do join these social handles so that our reach is increased. So this you should do on a personal basis as well as all your personal contacts. This is not restricted to the AIPSN audience only. It has to go beyond AIPSN. If AIPSN digital social media has to make an impact against all the junk that is being circulated on social media by you know whom. So thank you again for the speakers, and with this we can conclude the session, and do join us at the 2 workshops. Thank you.